Hi class, this is Miss Durley and this is Unit H, Part 1, our last unit before we're halfway. Very exciting. So the focus of this unit is enzymes, and in this unit we won't get directly to enzymes. We're going to be talking about it kind of indirectly, but the big idea of this unit, and this is a really big idea, we've seen it in Unit C, that if we change the shape of a molecule, and in particular here, we're going to be talking about the shape of an enzyme, which we maybe remember or need to remember very soon is a protein. So if we change the shape of a molecule, in particular a protein, it's going to change how that molecule functions, works, operates in our body. In this part of the unit, this kind of intro part, we're looking at the reactions of the human body and how they are regulated by hormones. So, some vocabulary words. Metabolism. Metabolism is going to be the sum total of all the chemical reactions that occur in our body. We're going to talk about that. A metabolic pathway is going to be a set of reactions that occur. Thyroxine is the hormone that we're going to discuss in this screencast, and the thyroid gland is the gland sitting on top of our trachea. We're going to see it in a diagram in a sec, that makes thyroxine. So human metabolism, and you are a human, you have a lot of reactions, chemical reactions that occur every day in your body. And so when we talk about your metabolism, and people might talk about it in general terms, we're talking about chemical reactions. We want to remember the correct terminology for chemical reactions, that on this side of the reaction we call these the reactants, and on this side we're talking about products, and we use an arrow in the middle to show it's making, and here plus is and. So we should have a general understanding that we're talking about a lot of chemical reactions. And these chemical reactions don't kind of happen hilly-nilly all randomly. They're going to follow a very specific pathway. And a pathway is going to be regulated by many things, or many different variables can regulate it. But one thing we need to understand in a metabolic pathway, that if this is the first reactant, the reactant becomes the product of the first reaction, and then it will become, I'm just going to try to get rid of that, it will become the reactant for the next reaction. So this was a product B, and now it's a reactant in the next, and then this product becomes the reactant, and so on. And in our body, in our metabolic pathways, each one of these is going to have an enzyme that is specific to it. And in this case, we're just representing it by the letter E with a number. So there would be 4 different enzymes that will regulate these individual reactions that all together add up to form a pathway. In one example, and this is a crazy diagram, but it has some pretty colors, so we could have a look at it. If we just look at one example, here's some glycogen into glucose, and there's a lot of different things that we can do with glucose, but here is one pathway that can lead to ATP. So this would be an example of a metabolic pathway, but we see this is just some metabolic pathways interconnected, right? Pretty complicated. We're not going to look at anything this complicated, but we should have an appreciation of metabolism, a lot of chemical reactions. Metabolic pathway is one particular path that leads to a end result. So metabolism, just like an orchestra, if you've ever been to the orchestra, needs regulation, and a conductor is such a regulator. We also should consider that at different times of the day, and you know this yourself, there you have your awake times, you have your tired times, and we have our awake times of the year when the sun shines. Usually we have more energy, and in the winter time we're usually feeling a little bit more tired. Our metabolism changes by time of day, time of year. So, one specific example of metabolic regulation is a hormone as we said at the beginning, made by this gland, butterfly-shaped gland sitting on top of our trachea. So if we put our hand on our throat right now, right where our Adam's apple or voice box is on the surface, it's flat, it sits right there. So the hormone it makes is thyroxine, and a hormone we want to remember is a chemical messenger. So this is a chemical that would travel through our bloodstream and target a part of our body. So hormones travel in the blood and they affect certain parts of the body. And in the case of thyroxine, thyroxine is going to affect our overall metabolic rate. So it's going to affect all our cells. So thyroxine controls the rate of the internal reactions, chemical reactions that occur in our body every day. In other words, it controls how quickly or how slowly these reactions occur. So for instance, when we get up in the morning, our metabolism is slower. And as we wake up, our body starts to release thyroxine. And the increase in thyroxine would result in increasing our metabolism. So we might start breathing, increasing our breathing rate, our heart rate would go up. These are the changes we would experience with an increase in our metabolic rate. So thyroid gland requires a trace element, and the trace element it requires is iodine. Iodine is only needed in small amounts. However, it is quite essential, and it would be actively transported into the cells of our thyroid gland. I'm just checking on the time. And so this would be an example of active transport. So the cells of the thyroid gland would require mitochondria to make ATP to actively transport the iodine in. So that's the reason why our salt that we use, if you went to your pantry right now, you'd see that it has iodine in it. It's iodized, and this is because we require it in our diet. Some things that can happen with low levels of iodine: an enlargement of your thyroid gland, referred to as goiter. So other things that can go wonky with your thyroid, you can experience hyperthyroidism. So this is too much thyroxine. You would need less sleep. You would feel speeded up. You would probably lose some weight. And you would need, eventually, if it gets severe, medical treatment. The reverse of this would be hypothyroidism. So this would be meaning your thyroid gland would be releasing not enough thyroxine. You would be feeling sluggish and tired, and you'd probably gain some body mass without doing anything differently in your life. So that is in general hyper and hypo. We could see some general changes to the body, but how specifically we want to consider, would a change in the levels of thyroxine affect the rate at which our mitochondria do cellular respiration? So this kind of brings the unit full circle back to unit A, that we want to consider oxygen plus glucose produce ATP, carbon dioxide, and water. We want to consider that if I increase thyroxine, so if thyroxine levels go up, then the metabolism of oxygen and glucose will go up because I need the output of more energy. This means that my breathing rate would go up, my heart rate would go up, my ability to run a little faster, right, would be enhanced because of the production of ATP. So we want to think of how thyroxine can affect us on an overall body metabolic rate, but we also want to consider how it would affect our cells and specifically how it would affect the mitochondria. So that's kind of the summation of the screencast. Can you explain how thyroxine affects our metabolic rate? And can you specifically explain how thyroxine might regulate cellular respiration? Hope that helped.